Local Deformable Precomputed Radiance Transfer, or LDPRT, captures spatially varying, realistic transfer effects on local geometry from a low-frequency lighting environment. Notice how the shadows change as we change the lighting environment or rotate the object. We can turn the transfer effects on and off to show how much soft shadows enhance appearance. LDPRT stores a transfer model at each point on the object. Unlike previous methods, this model can be quickly rotated to an arbitrary deformed frame. For the first time, this allows real-time transfer effects on deforming objects. Different textures can be mapped onto any static or deforming object, including diffuse, translucent, and glossy textures. LDPRT fits transfer using a sum of circularly symmetric zonal harmonics. As the number of lobes increases from 1 to 4, this approximation becomes very accurate. Larger error is visualized as brighter red. Here's what the scene looks like with increasing number of lobes. Finally, we visualize the transfer function and how it varies spatially. It can get quite complex in the partially shadowed regions. We then cycle through the 4 zonal harmonics whose sum approximates the transfer function. LDPRT captures general transfer effects. We begin with a rendering that integrates over the lighting environment but lacks local transfer effects. LDPRT captures soft shadows, a critical effect for shape perception. It also captures interreflection, which we toggle on and off here. Finally, it captures subsurface scatter to render convincing translucent surfaces. One method for building an LDPRT model is to specify a patch of local geometry or acquire it using computer vision. Given the geometry, we perform an offline simulation of transfer effects via ray tracing. We then fit a zonal harmonic model to the transfer signal. Finally, we can map the result onto a deforming object. This bat example applies a single lobe model representing subsurface scatter from a thin membrane. Notice how the light shines through the wings when they are backlit, but diffusely reflects when they are frontlit. We can also apply other local textures to the deforming bat to make this bumpy bat or this bat waffle. This example shows LDPRT mapped on a cylinder. In real time, we can change lighting and deform the object. Shadows and other transfer effects respond properly. Turning the transfer on and off shows how important it is for perceiving the local texture. Many types of textures can be applied to an object without knowing its shape or how it deforms. We can also apply the same textures to different objects. LDPRT provides compelling shading effects from local geometry on deforming objects.